everyone. Today we are going to study the chapter called Fourier series, which is highly used in all engineering branches, and this is very important for the engineering students of third and fourth semester. And I'll try to make it as very simple as you can easily remember the concept. So here I'm going to explain not in thoroughly of Fourier series. Instead, I'll give you 12 tips which will make you to easily understand the entire chapter of Fourier series. So the first tip is Fourier series is nothing but a sum of cosine and sine functions. That means your function or your formula will have a combination of cosine sine functions. And you will be having a 12 important tips here which will easy for you to understand the entire chapter. I request you to watch till the end of this video where you can have the generalized formula, use of Fourier series and lot more functions related to Fourier series. So in Fourier series, periodic function plays a very important role which we have studied in Laplace transform. A function f of x plus nt will be f of x. That means for a given period the function repeats its nature and then again and again. So here we are using the period of 2L. The entire Fourier series is defined for period 2L. So the length of the interval will always be 2L. So the length of interval should always be 2L because the Fourier series are periodic for the period 2L. So we are finding a generalized formula for Fourier series which will help you to directly solve the problem, or else you need to remember lot of formulas. The formulas for 0 to L, 0 to pi, pi to minus pi. We have so many intervals which will connect 0 to 2L. So we need to remember lot of intermediate formulas. But if you know this generalized formula, it'll be easy. You yourself can find the formula for given intervals. So what is the generalized formula for Fourier series? F of x is equal to a0 by 2 plus summation n is equal to 1 to infinity an cos n pi x by L plus summation n is equal to 1 to infinity bn sin n pi x by L. As I already stated, this is for interval c to c plus 2L. When you take the length, it will be for 2L. C and c minus will get cancelled out. You have interval for 2. The name indicates it's a series. You will have sum of terms where you have to find the constants values a0, an and bn. These are nothing but the constants whose formulas are obtained by Euler, which is given by a0 is equal to 1 by L. Since our length is c to c plus 2L, you have to integrate for the complete length c to c plus 2L, f of x into dx. An is 1 by L, and you can see an is a coefficient of cos function. So c to c plus 2L f of x cos n pi x by L into dx. And bn is a coefficient of sine function, so it is 1 by L, c to c plus 2L f of x sin n pi x by L into dx. So the last point which you have to remember before you start the Fourier problems on Fouriers, that is Dirichlet condition. This is very important. Why we say important is whatever f of x we have written, it was called a trigonometric series. Initially it was named as trigonometric series. Later Dirichlet condition exists. What Dirichlet condition state is, whatever the function you are going to choose, the function should be a single valued and it should be finite quantity. And whatever the function we take, it should be in the interval 0 to 2L. That is 2L should be the length of the interval. And it has only a finite number of discontinuous points. Whatever the function we take, it should be a finite discontinuous point. And it should have the utmost finite number of maxima and minima for c to c plus 2L. Keeping all this condition along with trigonometric series, a function f of x is defined, and if it satisfies the Dirichlet condition, then this trigonometric series was later named as Fourier series. So coming to the sixth point before you go to the problems of Fourier series, whatever the functions they have given, please check whether the function is even or odd. So when I say the function even or odd, sine is always an odd function, cos will be an even function. So when it is an even, we say it is cos, and if it is odd, we say it is sine function. Detailedly I'll explain it. Just remember, cos will be an even function and sine will be an odd function. This is mandatory before you start the Fourier series. The seventh point, if you know the function is even function, your entire Fourier series can be reduced just by finding a naught an, because the Fourier series has cos and sine functions. If you know it is an even function, you need only cos. Bn stands for the coefficient of sine. It becomes 0. If you know the function is an odd, then you just have to find Bn, because Bn is only a sine function. A0 and An are cos, that is even function. It automatically becomes 0. Even if you solve and check, you will get the answer 0 itself. The ninth point which you have to remember, okay, we said even and odd. How we are going to check whether the function is even or odd? To check whether the function is even or odd, we have two types of intervals here. One, you have the interval of the form 0 to 2l. The another will be of the form minus l to l. That we'll see later. If suppose your interval is of the form 0 to 2l, what you have to do? For the function, you replace x by 2l minus x. This is nothing but the periodic function which you're doing it. Okay. When you replace x by 2l minus x, see here. For the function, replace x by 2l minus x. After replacing, if your function is again f of x, right? For the function, you replace 2l minus x. That means you are checking the periodic condition. If you get back the function without any sign difference, then we say it is an even function. If it is an even function, go back to the seventh point. Find a0 and an, bn will be 0, because bn is a sine function. And as I said, if it is an even function, it will be a cosine function only. And for same function, if you replace 2l minus n, x, and if you get back negative of the function, see the difference. If it is f of x, it is even. If you get negative of the function, then it is said to be odd. If it is an odd function, go back to 8th point. Bn you have to find, because a0 and an are even function, they become 0. And your function or a series will be a sine function. This is in case if you have 0 to 2l. This is how you have to check whether the function is even or odd. If suppose you have an interval of this form, minus l to l, you can check the length of the interval. L minus of l will be 2l. Always it has to satisfy 2l property, right? If the interval is minus l to l, here we replace 2l minus x to x. In this case, you have to just replace x by minus x to the function. So when you replace x by minus x, x by minus x, if you get back the function without any sign difference, then it is even. So if it is an even function, go back to the seventh point. You have to just find a0 an, and it will be a cosine function. If you get negative of the function, then we say it is an odd function. Just find bn, then that will be a sine function. So the 12th point is, if you are able to distinguish whether the function is even or odd, what will happen to the Fourier series then? Actually, the Fourier series has a0, an and bn, right? If you are able to say the function is even, then you just write the Fourier series a0 by 2 summation 1 to infinity an cos n pi x by l. Don't write bn term, as we already stated, if it is even, bn terms will be 0. Okay. And a0 by 2, why we are writing? Because it is divisible by 2, so it will also be an even function here. And if it is an odd function, you just have to write the Fourier series bn, sine n pi x by l. As we already stated, if it is an odd function, a0 and an will be 0. So the entire Fourier series will be cut down to bn. So once even and odd is done, your formula of Fourier series is being reduced. So formula for a0 an will also change. Why? Because when we say the function is a0, an and bn, this is what we call neither even nor odd case. You can find all a0, an, bn when the function, you are able to not distinguish whether it's an even or odd. You have to find all the values a0, an and bn. Okay. That case, your formula was 1 by L and you had complete interval because this was defined for C to C plus 2L, right? But when you're able to distinguish the formula as even or odd, okay, if it is even, we don't want this bn term because it's a sine function. If it is odd, we don't want this a0 and an. That means a combination of sine plus cosine has been cut, right? So in that case, a0 will be half, that is 2 by L 0 to L f of x dx. C to C plus 2L will be breakdown into half. Instead of 2L, you will have only half of it, that is 0 to L. The other terms remains the same, only difference is if it is neither even nor odd, 1 by L C to C plus 2L. If it is even or odd function, it is 2 by L integral 0 to L. So these are the very important 12 points before you start the problem on Fourier series. So my positive note is, before you start a problem in Fourier series, make sure you are checking whether the function is even or function is odd. As I already given the points, you have to check functions even and odd. It will be easy to eliminate our constant. If it is even, I just have to find only a0, an because I know bn becomes 0 because it's an odd function. If it is odd function, you just have to find only one term, that is bn. a0, an will not exist. Even if you find, the answer will be 0. So that is the easiest way of approach by using generalized formula of Fourier series. So problems we will try to meet in the next video. Thanks for your time. Bye.